Hello, my name is Vamsi Sisla. Today, my talk's title is NLP Models Tainted by the Biases. Here's my quick background. I'm currently working as a head of data science and machine learning at Unify Consulting. I have a special interest in ML ops and NLP. I'm also pursuing a master's in data sciences at UC Berkeley, and I do ad hoc research in NLP. In the past, I've done 2 startups as a founding CTO, exited 1 startup in 2017. So the broad themes of my talk are, I'll set the stage for biases, which most of you should be aware by now, and also talk about biases in NLP models and how we are getting biases in NLP models, and top it off with current research and future possibilities in addressing these biases. So the quick definition-wise, according to Wikipedia, a bias is a disproportionate weight in favor of or against an idea or a thing. Biases dictate our behavior, our response towards our surroundings. Bias in human societies has been there. It's as old as humans, as you know, right? Some of these biases are so innate, we are even calling them unconscious biases. Some biases, we pick up from our surroundings and our upbringing. Only in the last century or so, or even later part of last century, is when we started to address these biases, and honestly, we have a long way to go. So for the longest time, we have biases that are unconscious as well as culture-wide, and we've been slowly addressing those biases. And these biases are pretty evident in the historic text. When I say historic, I'm not talking about mythological, ancient texts. I'm talking about any text in the past 2,000, 3,000, 5,000 years, right? And if you look at our current social media or popular media or news outlets, biases are littered all across in the corpus of data. The damage caused by the biased content in our AI and ML has not been really acknowledged yet. Only recently, we're starting to see some of the researchers working on this. We'll start to see more and more attention towards addressing these biases around us. So obviously, when we are training NLP models using this historic data and our social media content, our news and popular media content, bias does seep into our NLP models. And that's just a fact of life, because the model is training based on the data that you're feeding. And if the data already has some inherent biases, it's going to pick it up, right? Whether you're using 8,000 digitized textbooks to train a pre-trained GPT-3 model, or for that matter, any smaller model that uses any of the popular NLP datasets, there's a good chance that the dataset is already influencing its biases into the model, into the pre-trained model. It's funny, as parents and teachers, we are able to shield our children and our current and future generation kids from getting exposed to such biases, but we're not able to do that with the NLP models that we are churning up these days, because we haven't really figured out a way to solve that problem at scale. For example, there are natural imbalances in the data set. And when you train the model to, say, predict the gender or race or what have you, the biases in the data set end up magnifying in the model's interpretation, right? And when you're training these data sets and creating these pre-trained models, those models come with those biases. The bottom line is there's plenty of evidence that these pre-trained NLP models have various biases that are undoubtedly present in the corpora they are trained on, and that directly or indirectly creating harm to our society currently as well as in future. So now that we established what are biases and biases exist in NLP, I want to give a couple of examples in the interest of time using two popular data sets and talk about the potential biases that data set could contribute into the models that are built on those data sets. For example, book crossing analysis data set contains about 270 users providing over 1.1 million ratings, about 271,000 books. It's actually 270,000 users and 271,000 books. Out of that, 70% of these users are from the US and Canada. And the countries that have very high percentage of readers are not even represented in this corpus. For example, India, on average, readers would read about 11 hours per day. They are not even represented in this data set. And why is this critical or why is this important? Reviewer country's origin will have a significant impact on the review for a certain topic, especially some of those controversial topics or topics with a lot of diversity in opinion, cultural in nature, religious in nature, political in nature, and so forth. For example, perceptions of a Western reader on Eastern philosophies, opinions about communism, certain religions, alternative medicine widely differ from readers from the US to readers from, let's say, Asian countries. Similarly, 82% of the reviewers are in the age bracket of 25 to 64, whereas less than 50% of the world's population is in that age bracket. So you see there is a disproportionate representation of that age bracket in the data set. For example, 1.6% of the reviewers are in the age bracket of 65 years or older, whereas 8.3% of the world's population is in this age bracket. So this difference in the age bracket distribution could lead to biases against those age groups that are not represented properly in the data set. Similarly, if you look at another popular data set, SQUAD, data set created by Stanford researchers, is built based on the top 10,000 Wikipedia articles. But there is a higher percentage of these articles are coming from popular media such as music or sports and so forth. There is very less number of articles are coming from, let's say, the scientific community. For example, you will get more articles when you search for music in this data set than cancer or leukemia, right? Not only that, these are most of these articles are quite popular in English-speaking countries in the western parts of the world compared to non-English-speaking eastern parts of the world, right? So this leads to many biases that are inherent in the Wikipedia data set itself. So any model that built using this data set will carry biases against certain groups or certain regions or certain countries and so forth. So now that we established biases exist in our data set, which means biases exist in our models, what are our options? Where can we go from here? There is a lot of research being done to address some of this work, right? For example, some of the researchers are approaching data sets as a bias police, right? For example, this data set stereo set is a data set that's created by MIT researcher that measures stereotype biases in language models. This consists of about 17,000 sentences that measure models' preferences across gender, race, religion, and profession. So using this data set, you can take your NLP model and see how well your model performs against this data set that is actually checking for stereotyping in your model. So it's a really nifty tool. You can check your Bird, Roberta, Elmo, any of the popular NLP models against this data set. Excuse me. Similarly, another data set called anti-reflexive bias challenge data set. This data set is created for detecting gender bias that leads to unambiguously wrong model predictions. Okay, and this is fairly common in some of the European languages like Russian and Sweden. So this is a pretty good data set you want to use, especially when you're targeting your NLP models in those languages in European counterparts. And finally, the third example I can give is crowdsourced stereotype pairs benchmark. This is relatively new, but fairly small data set. It's about 1,500 examples that cover stereotypes dealing with 9 different types of data biases, 9 different types. So using this data set, you'll be able to check against your model to see how well your model is performing against this data set, against these 9 stereotypes. Similarly, if you try to look at making enhancements to the current model, maybe coming up with a new architecture or tweaking the existing architecture, there are a handful of researchers solving these problems as well, solving the bias as well through these methods. So one of the research I can talk about or mention is investigating gender bias in BERT. These guys have proposed an algorithm that identifies gender direction in each BERT layer. And they show that removing that embedding components in such directions achieves greater success in reducing BERT-induced biases in the downstream tasks. So you should definitely check it out if you are interested in learning more about how this research group has solved or trying to reduce the impact of biases induced by your NLP pre-trained models. Similarly, there are a few other examples I've listed here. I will not be able to cover all of them in the interest of time, but let's go to a few more examples with respect to what we can do as a society to address these challenges. Fundamentally, this is fairly serious. We don't teach our children at home or school to be against with biased viewpoints or opinions. Then why are we training our NLP models using such a tainted data set? So a disciplined way to create future data sets in such a way that these inherent and unconscious biases are not embedded is a preferred approach. That way you're not having to go and retrain or retune or modify your existing architectures to solve those problems in the downstream. Not only that, let's say you already have existing data sets, whether it's 8,000 digitized books or any of the most popular NLP models. We can use better debiasing techniques to scrap out all these inherent and unconscious biases. There are quite a few techniques that are being tested right now, but further work is required. Similarly, continuing on the current theme of changing architectures, we should build models that ignore biased data while still preserving the performance of the model. Let's say you did your best to clean all the biased data, but you still cannot ensure or guarantee that there is 100% clean. Then you want to build models and architectures that can actually ignore the biased data, right? Training the model to do the primary task really well, but also perform poorly on all the stereotypical tasks is one way of solving this problem. And we are seeing one or two such efforts in other non-NLP related use cases, but I feel there is a lot of promise in addressing the bias by modifying the architecture of the current popular models. So that concludes all the topics I wanted to cover in the time I was given. I'm happy to answer any questions you may have.